Part two. So we do questions 11 through the end, whatever it was. I think it was 20. So that's my plan. So let's just keep on going. So again, this is the chapter 4 recording, sorry, chapter 4 review, part 1, part 2 of that review. So question 11, find the extreme values, both relative and absolute is another way of saying that. Okay, so relative in a local, a given region, and global, absolute, the biggest. Okay, so that's our plan. So in order to do either one of those, the first thing I need to do is find critical values. Critical values, again, is where my derivative is 0 or undefined. So my first step is find the derivative. So here's my derivative, sitting right here. I think that's pretty straightforward. I don't need to talk through that one. This will never be undefined, so I'm just looking for where this is equal to 0. This one is not factorable, so it's either quadratic formula or it's your solving, went blank, my solving feature on the calculator. Okay, so when you do that, you'll get these two values. I don't know if I need to do that or not. I'm just going to go ahead and do that real quick. So I'm going to jump down there. There's a couple things that we need to see on this just to make sure that we know the little tricks on this. So we're going to go to menu. We're going to go to algebra. We're going to go to solve. And remember my derivative. Grab off the paper here. Instead of looking back and forth. Maybe. There we go. So my derivative was 6 x squared minus 6x minus 10. Now that's all pretty straightforward. Equals 0, comma x. But here's the thing to remember, and I don't think it matters for this one, but it does matter for the next one. I'm gonna go over here. Remember how we did that before? Such that. So I'm looking at this guy right here, and I want to go back here to my equal sign. Oh no, sorry, don't want that yet. I want x to be between, since I have a closed interval, I want the x's that I solve for to be between -3. When I go control equals to grab that inequality symbol, and I have x, and go back to control equals, grab that inequality symbol, and +3. So now all the answers that the calculator will generate has to be between those two. And I'm going to go control enter to get my approximates. Okay, so that's where I got my -0.88, the 1.88, etc. Okay, so that's where these came from. These are in my interval, so we're good to go. And then I want to check to the left of the -0.88, in between, and to the right. Why am I doing that? For my local or my relative extrema. Since I'm increasing on this side and decreasing on this side, f of 0.88, -0.88, must be a relative max. That's this right here. F of 1.88, going from decreasing, so it's decreasing here. I can go ahead and show that, I guess. So we're increasing to decreasing, and then we're back to increasing. So this is a min, and this is a max. Okay? So this is a relative min. Okay, where did this come from? So I just took this -0.88, etc. I plugged this whole mess into my function, and I found the value. I took the 1.88, the whole entire thing, and plugged it into my x value into the original function. And that gave me my two y values, because it says find each point. It doesn't say just x coordinates, so I needed the x and the y. Okay, so that's for relative. Relative or local min and max. We do the first derivative test or the second derivative test and find out which ones are mins and maxes. Okay, now global. So now I want to look at those, and I want to check the endpoints. So I took a -3 and plugged it in, took a +3 and plugged it in, and I got these values. For absolute or global, this is the smallest in that region, so it's my absolute min. This is the largest, so it's my absolute max. Yes, it happens to be also a relative max because it's larger than anything in that area. And this is my relative min. Okay? All right. I think that's good for 11. Question 12. Let f be some function with derivative given by this. Okay, this is my derivative. On which of the following intervals is it as f decreasing? A decreasing function is when f prime is less than 0. F is decreasing when f prime is less than 0. So I have to figure out where this is equal to 0. And then or undefined, because that's where it's going to switch from increasing to decreasing or vice versa. So this is undefined when the denominator is 0, so at x equals 0. This is equal to 0. I'm going to add the 2 over x to both sides. I'm going to cross multiply. So I get x cubed equals 2. Take the cube root, and I get these two critical values. Had you not done the undefined part, you would have missed this 0, and you would not got that answer. Be careful. Undefined or equal to 0. Okay, now I'm going to check regions. So I check to the left of 0. So plug in a negative value. So like a -1 makes this positive. This is always positive, and so my derivative is positive when it's less than 1. Sorry, less than 0. Between 0 and cube root of 2, what's the cube root of 2? Like 1 point something, right? So let me try 1. I plug in 1, 2 minus 2 divided by 1 is 2. 1 minus 2 is negative, so it's negative between here and here. Something greater than 2, like greater than cube root of 2, something like 4. 4 squared is 16 minus whatever that's going to come out to be, which is a half, then get a positive number. Where is it decreasing? Or where is my first derivative negative? From 0 to cube root of 2. Notice they do include the endpoint. Again, we've talked about that. You just have to find it in multiple choice. Sometimes it's open and sometimes it's closed. Why is this one open? Because it's undefined at 0. Okay? Your actual derivative, your actual function is undefined at 0 also. If we went backwards, which we don't know how to do yet. All right, so there's 12. 13. All right, let f be some function given by this equation. So now we're looking at the function, not the derivative. So be careful. Looking at the interval from 0 to 2 pi. Where's my graph? Concave down. Concave down. Second derivative less than 0. Question 12. Where's it decreasing? First derivative less than 0. Okay, so as you read this, try to translate what these things mean into a procedure, okay, or what I'm looking for. All right, so second derivative. So I took my first derivative. You could do this on the calculator. Okay, this would be definitely like a calculator type question. So you could do this on the calculator, and you could do this on the calculator. But you can see my work. You can hit pause and look through that. I think it's pretty straightforward. It's product rule, derivative of the first times the second plus the first times the derivative of the second. Don't forget the inside function's derivative. Oh, sorry. Inside function derivative is 2. Don't forget that one. Okay. And then all I did is just did a little simplifying. 2 times 2 is 4. And then I found the derivative of that. Okay. This is not product rule because 2 is not a variable. 2 is just a constant. So this is not product rule. So it's just 2 times the derivative of sine. Inside function has the 2. This becomes a 4x. So I took the derivative of the first times the second plus the first times the derivative of the second. Again, don't forget the 2. I combined some like terms and I got that there. Okay, on a calculator, I'm going to put this in and I'm going to solve. These are sines and cosines, so I'm going to get an infinite number of values. So I really want to restrict my domain here. So I'm going to go back down here to the solver, and I'm going to solve. So I go math, or menu, sorry, algebra, solve, and I'm going to type in my function. Let me find on the other paper. So my function I'm trying to solve for is 8 cosine 2x. So I'll go here to trig. Again, don't type in the cosine, use the trig. Cosine of 2x. I'm going to go 2 times x just to make sure. Sometimes it doesn't like just 2x. Minus 8x times cosine, no, sine, glad I caught that, of 2x. Notice they automatically put the parentheses in there. If they didn't, you'd want to make sure that's in parentheses. And I'm going to go back to my times just because sometimes it gives me really weird answers when I don't do that. It shouldn't, but it does sometimes. Equals 0, comma x. I'm just going to double check I typed it in right. 8 cosine 2x minus 8x sine 2x equals 0. Okay. Let's bounce outside that thing. And let's do our such that. So I do control equals, go over here to the corner, grab that such that, and I'm going from 0 back to my equal sign. Is this a pain? Yeah, but super important that you do this because otherwise you're going to get a lot of values that are not in your interval and you're going to end up scrolling through trying to find your answers, and it can get messy. All right, going from 0 to 2 pi. Think I'm all good. Hit equals, and there's my values. Why do I get this? There's just something about it I didn't like. Um, it doesn't mean I did it wrong. It just means that there's something that I need to look at more carefully. All right, so there's still more over here because of that guy right there. So I'm going to scroll over and find the last one there. Okay, you can hit pause if you don't have that done and write those down. But here they are right here. And again, you can hit pause and write those down. Okay, I did first derivative test. No, I didn't either. I did second derivative, not test, but just second derivative. And I put all these on a number line simply because I need to look at the intervals between to make sure I find all of the times where it's negative. These are all the places where my second derivative is 0. So your values will change signs at that 0. So now I need to look to the left and to the right to see where is it positive and where is it negative. And I simply plugged in something like 0.25, something between 0 and 0.5, into my second derivative, and I got a value, and that was positive. Then I plugged in something between these two, and I got a value, and that's negative. Now, we can save ourselves a lot of work. We can tell that this does not have a square term. It doesn't have anything that's weird that's going to cause my second derivative to not change signs from one side of the 0 to the next. So once I get to here, I'm simply just going to fill in the rest, alternating plus minus plus minus. Okay, concave down in this interval and this interval. So you can see my answer key. My interval is from 0.5 to, I know I typed the whole thing, 0.538. 3 decimal places is enough. And then 1.822. So it's from that interval, in that interval, and in this interval. Okay? All right. Yeah, I guess on my answer key I wrote all the decimal places. Nearest 3 decimal places is all they want. 3 decimal places. All right. Question 14. I cheated and I typed this in ahead of time. Relative extrema. We already did this once. Back when we had that local global question back in chapter or question 11. So relative extrema correct critical values of f, which is where my first derivative is 0 or undefined. And this is not dependent upon an open or a closed interval. Relative extrema always occur at critical values, whether it's open or closed. Okay. Absolute extrema, if it's continuous. Okay, so if my f of x is continuous on a closed interval, then there must be absolute extrema. So up here it asks me, do all closed intervals have absolute extrema? Yes, if my function's continuous. Not differentiable, doesn't need to be differentiable. It needs to be continuous. Okay, extreme value theorem. If f of x is continuous, guaranteed there must be absolute extrema. Where do they occur? At critical values or at endpoints. Okay, so open intervals, if you have an open interval, you are not guaranteed to have an absolute extrema. You might, but you're not guaranteed to have an absolute extrema. It must be a closed interval for you to be guaranteed. So do all open intervals have absolute extrema? No. Some, but not all. Okay. 15. And this is where I kind of didn't get any more after this done ahead of time, so I'll just have to start doing them as we go. So, question 15, over what interval is the graph of that increasing? Increasing is where my derivative is positive. So my first step is to find the derivative. Okay, so let's do quotient rule. Derivative of the top times the bottom minus the top times the derivative of bottom all over the bottom squared. Whoops. Okay, simplifying the top a little bit, I get x squared plus 1 minus 2x squared, which gives me a negative x squared plus 1 all over x squared plus 1 squared. So first derivative equal to 0 or undefined. So where's my first derivative undefined? Where the bottom is 0. When will x squared plus 1 equal 0? Never. This is always positive, and if I'm adding 1 to it, it'll never be negative, or sorry, never be 0. Okay, so forget undefined. Let's go to here. Where is my top 0? Well, if this is a negative 1, then negative 1 plus 1 is 0. So when x equals plus or minus 1. Look at a number line, negative 1, positive 1. Let's check values to the left of negative 1. This is always positive, so let's ignore the bottom. Plugging in like negative 2. Negative 2 squared is a positive 4, but this makes it a negative 4 plus 1, negative. Put in something like 0. 0 squared is positive, 0 makes that a negative 0, which is 0, plus 1 is positive. Put in something greater than 1, like 3. 3 squared is 9, negative 9 plus 1 is negative. So where is it increasing? From negative infinity, negative 1 to 1. So from a negative 1 to 1, my first derivative is positive. So my function is increasing. Where is it decreasing? From negative infinity to negative 1, and from 1 to infinity. Now you can put brackets on this or parentheses. I'm not going to take it off, but you should never have a bracket on the infinity side. Okay. There's question 15. Question 16. We have a rectangle. We want a rectangle whose base is on the x-axis, inscribed under the graph of that. Find the height of the rectangle with largest possible area. So as soon as I see that phrase, I'm thinking optimization type problem. And I need to write an equation of what I'm trying to minimize or maximize. Well, I can't really write my equation until I know what this thing looks like. So let's graph this thing. This has a vertex. I could write this like this. Okay, so I can write my graph like, or my equation like that. So at 2, I have a vertex and it opens down. I'm going to inscribe a rectangle inside that upside down parabola. I'm going to call this point right here just some random xy because I don't know how big it is. I don't know where that's going to be. This is just some xy coordinate. And that's what I need to find. Okay, area equals length times width. So my width is y, my length is 2x. Why is it 2x? Because one side of the rectangle is x, the other side is x. Remember what we said, this point right here is xy. So the distance from here to here is simply the x coordinate of that, and the y is the height. Okay, now I need to change this so it only has one variable. So I'm going to get that y out of there and rewrite it in terms of x. So in terms of x is my equation, 2 minus x squared times 2x. Okay, and so a equals, multiply, and we get 4x minus 2x cubed. And then I'm going to set that equal to 0. And I'm going to solve that. Factor out a 2x. And I get what? Factor 2x, I get a 2 minus x squared. Oh, I forgot to take the derivative. Sorry, someone just walked in the room and I got sidetracked by them and I lost track of what I was doing. All right, here we go. Start over. So my derivative is going to be 4 minus 6x squared. Set that equal to 0. Add the 6x squared to the other side. Why? Just to make it positive. Divide. Take the square root and simplify at the same time because we're AP Calc. We can handle that. Okay. And we're done. So how far over should I go? 2 squared to 3 in this direction and 2 squared to 3 in that direction. Okay, so now we need to find the y value. Oh, hang on. That was on top. It's just a 2, not a, maybe we're in AP Calc, but your instructor can't do math still. So square root of 4 is 2. And I guess I was still right. Never mind. I was okay. We were still okay with that, what I had before. I had just written it different on my answer key, so I was second guessing what I had here. We're still okay. All right, now we're going to take that and plug it in for x right here. And so y equals a negative of that mess squared. And we get a negative. When you square the square root, it goes away. And so we have a positive 1 1/3. Question said find the height. Done. It could have asked lots of questions. What is the largest possible area? Then I take those two values and I plug it into here. I don't need the negative one. I would just take in that value and I would take in that value and stick it into my area. Okay, but the question was find height. There's my height. Okay, sorry about that. When the person walked in, it threw me all off. All right, question 17. Television camera on the ground level filming the liftoff lift off of the space shuttle. Okay, so space shuttle is going to go straight up. Okay, according to this position, so my height is equal to 50 t squared. S is measured in feet and time is measured in seconds. Camera is 2,000 feet from the launch pad, so this is a constant, so I can put it in right now. Angle of elevation is this guy right here. Find the rate of change of the angle of elevation of the camera 10 seconds after liftoff. Okay, so I need an equation that relates this side to this side, and that would be tangent. So tangent of theta equals opposite, which we don't know, S over adjacent, which is 2,000. Okay, take the derivative of this with respect to time. So tangent derivative is secant squared times the derivative of the inside function, which is d theta dt. This is the same thing as 1 over 2,000 s. So this is just a constant. So my derivative is just 1 over 2,000 times ds dt. So I need to go back here and find my derivative of s. So ds dt equals 100 t times dt dt, which doesn't make sense, or it does make sense. It's just 1. So I have, let me stick it in right here. So 1 over 2,000 times, plug in 10 for t, because it's 10 seconds after liftoff. Whoops, 10, not 1,000, or not 100. Okay, work it out, and I get what, 1,000 over 2,000, so 1/2. Let's go back over here and plug in things also. So secant squared, going back to this guy over here, at time equal 10, this is 100 times 50, which would be 5,000. So at time equals 10, my S becomes 5,000. So a squared plus b squared equals c squared. Square rooted gives me this mess up here. And if we grab a calculator and type that in, we get 5,385.16. So there's my hypotenuse. Secant is the reciprocal of cosine. So cosine is adjacent over hypotenuse. So cosecant will be hypotenuse over adjacent. So it's going to be 5,385.16 divided by 2,000 parentheses squared. Now, if I'm doing this on the calculator, I'm going to keep this huge number that I got. I'm not going to write that 0.16. I'm going to grab that value from my calculator and pull it down when I do this calculation. All right, so this becomes a 1/2 over here. Divide that 1/2 by this big mess, and I'm going to get my d theta dt. Do we all see that? Grab a calculator, type that in, you should get 1/2, 0.5. Then divide it by this big mess off a calculator. My final value should be 0.0095 radians per second. Okay. Had one very similar to that on the last quiz, so that one should be semi-familiar. All right. Pyramid-shaped tank is a square base with sides of length 12, and the vertex of the pyramid is 10 feet above the base. So you would picture this kind of being upside down, but it's not. My pyramid is right side up, and the vertex is 10 feet above. So let's just draw a little pyramid. We have this goes back. Square base, this is 10 feet. I'm not going to try to draw it because it'll make a mess. Tank is being filled. The tank is filled. Oh, sorry, side length of 12. Let me put all my information in here. And this height over here is 10. And again, I'm not going to draw that in, but I'll just put 10 equals H. Okay, tank is filled to a depth of 4 feet. So this right here is my tank level, and this is 4 feet. Okay, water's flowing into the tank at a rate of 2 cubic feet per minute. So I know my volume rate of change. So dV dt is equal to a positive 2 cubic feet per minute. Find the rate of change of the depth of the water in the tank when the depth is 4 feet. So I know that H or D, however you want to call it, D is equal to 4. So I guess this is not my H, this is actually my D, but yeah, we'll change it to D because that's what I have on my answer key. All right, so here we go. So I need to write an equation for volume. Go back to the first page. Volume of a cone or a pyramid or anything that has a conic shape, not conic, cone shape, yeah, conic shape, has a point on it, is going to be 1/3 area of the base times the height. Area of my base is the length squared times the height squared. I called the height the depth. 1/3 area of the base times the height. Okay, and then so now if we keep going, looking at my answer key, I just caught this. I did it wrong on my answer key. So we got to be careful on this one. My shape of my water is not a cone. The shape of my water, it's not a pyramid. The shape of my water is what fancy name is. It's a truncated pyramid. My pyramid shape is this piece up here, right? That's my pyramid shape. This water is not, it's flat on top. So I'm actually going to have to take the volume of the full pyramid, right? The volume of the total, and minus the volume of the top. Okay, minus the volume of this piece here. So what's the volume of the whole entire pyramid? This will be a constant, so I can find this before I take the derivative. Okay, so there's my volume of the whole entire pyramid. So the volume of the total, I'll just call it tot, 1/3 the length, which is 12, squared, times the height, the depth, which is 10. So my full volume is 1/3 of 144 is what? 30. I don't have a calculator handy. 1 second, I'm gonna hit pause and go grab a calculator. So 1/3 of 144 right here is 48 times 10 gives me 480. So this guy right here is 480. That's the whole volume. Now the volume of my what's up here, this guy up here, is going to be 1/3. But now my length and my depth are going to change. Those are variables depending upon the depth. So in this case, my depth is 4, so I need some ratio of how to find the height and the length of my pyramid as time's changing. So going back to the idea that we did a while back, so the length divided by the depth is going to equal 12 over 10. Doing a little cross multiplying and solving, I get the length of this is going to be 3/5 the depth. not skipping steps. Let me do it over here on the side. I get 10L cross multiplying. So I get 10L equals 12D. Divide, and L equals, can I do that upside down? L over D equals 10 over, sorry. My equilateral triangle is not the same as that. This distance right here is 6, right? So this here, this triangle is not the same. So I guess we're fine with this whole thing. It's going to be 12. Yeah, we're good. Not 3 over 5 though. That was on my answer key. It's a little different because I did a little different than what my answer key was. So this is going to be 12 over 10, which is 6 over 5. All right, so there's my length and my relationship between length and depth. So the volume of the top pyramid is going to be 1/3 length, which is going to be 6/5 D squared times D. Do a little quick calculation. So we get 36 divided by 3, so 12 over 25 D cubed. 36 divided by 3 is 12. 5 squared is 25. Okay, so there's the volume of my top piece. So my total volume is going to be 480 minus that expression, 12 over 25 D cubed. That's the volume of this right here. All right. What's my definition of D? In this case, I defined D to be from here up, right? That's how I defined my D. Not my D. Yeah, my depth, my D, from here up. Okay? So making sure we're clear of what my D was. In this picture, the D was from there up. So now my D actually is not 4. My D is 8. The depth of the water is 4, but my picture I drew for the pyramid I'm subtracting, the depth is 8. That'll show up here in a second. All right, so dV dt equals, derivative 480 goes away. Plug in this, or multiply this 3 times the 12, I get negative 36 over 25 d squared times, this is a weird one, dd, change in depth, over time. All right, I know dV dt is 2. I know my d is 8. And my, what is the rate of change of the depth of the water? And my dd dt is what I'm solving for. So solve this big mess. I'm gonna grab a calculator real quick and type that in. So when I solve that, I get negative 0.17. Whoops, 0.17 equals dd dt. Remember my definition of depth, or definition of d was this depth right here. So the depth of the pyramid is decreasing by 0.17 feet per minute as water flows into the tank. Now, I just noticed that when I started this video that the depth is down here. That's what we really wanted. So if I were to really do this correctly, I should have gone 12 minus D was the height of the pyramid, and then I could have solved that and got a better representation how the depth of the water changes. But this is the depth of the difference up here, and I don't want to redo it. Maybe we'll check, and maybe I'll do it on the side and I'll post it. I don't want to take up more time in the video, spend a lot of time on this problem. But so this is that there, and if I were to do it again, I'd have done this as my H plugged into my equation. All right. Sorry, that was kind of stumbling through that one. Question 19. Kind of a weird one. 4 feet of wire is to be used to make 2 shapes, a square and a circle. Okay, so 4 feet of wire to make a square and a circle. So the surface, not surface area, the perimeter of my square is 4 times x, where I'm going to call x the side length. The circumference of a circle is 2 pi r, so I'll have 2 pi times y. Now, the total amount of wire used is 4. Okay, how much wire should be used for a square and how much for the circle to get maximum total area? Area of the square, x squared. Area of the circle, pi times r squared. So there's the area formula for what I'm trying to maximize. I don't want 2 variables, I just want 1. I can solve this for either x or for y. They're both going to be a mess. So let's solve for x. Maybe a little bit less messy. So I have 4x equals 4 minus 2 pi y. Divide, and I get x equals 4 minus 2 pi y over 4. So I'm going to plug that in for x. So I get 4 minus 2 pi y over 4 squared plus pi y squared equals a. Okay. Now, take the derivative of that, and I'm going to do that on the calculator. Okay. Take the derivative of this mess on the calculator and set that equal to 0. Okay. And when we do that, we should get y equals 0.28. So that is my radius of the circle. So I plug in that into here to find out how much to be used for the circle. And did I do that? I did. And so I get for the circle, we should be using, and again, I'm taking this 0.280 and plugging it in right here for y to find out how much for the circle, the circumference of the circle. And I get 1.760. Take that 1.760, subtract it from 4, and then divide by 4, and I get my square. Should come out to be 2.24. Let's double check. That plus that should equal 4, and it does. Okay, last one. Okay, we have 216 square meters. So I know I'm talking about area, and we're looking at making a rectangle divided into 2 parts. 2 equal parts by a fence running parallel to one of the sides. You could have gone this way. There's nothing in the directions that said I couldn't go this way. So what are the dimensions for the outer rectangle, this big, huge thing that'll yield the smallest total, the smallest, it's getting late in the day, the smallest total length of fence. Okay, so we can call this a bunch of different things. I'm going to call this whole entire distance y and this whole entire distance y. You could have made this y and this y. You just had different equations for your area and so on, but that's okay. And these are all x's. They're all the same. So I have x's. So now here's what I know. 216 square meters of pea patch. We want that much area. How do you find the area? Length times width. Length is x, width is y, x times y equals 216. We want the dimensions to yield the smallest total length of fence. So how much is my fencing? 3x plus 2y equals, I'll call it perimeter. Solve this up here for one of my variables. So 216 divided by x equals y. Plug that in. So 3x plus 2 times 216 over x equals p. Multiply 3x equals, no it doesn't, 3x plus, what is that, 432? 216, yep, 432 over x. Man, I made another mistake on my answer key. That's what I get for trying to do it all in my head. And we're going to take the derivative of that thing. So p prime equals 3. Now, this is 432 times x to the negative 1, right? This is 432 times 1 over x, which is x to the negative first power. So my derivative becomes a negative 432. Decrease that x 1 by 1 becomes a negative 2, so the x becomes an x squared. Okay. When is this equal to 0? At x equals 0. So there is a minimum at x equals 0. When there's no side length, you'll have no, well, I guess that doesn't make sense. You'll have a maximum. Sorry, you'll have a maximum there, not a minimum. That'll give you the most fencing required. All right, so let's set this thing equal to 0 and solve. So I'm going to add the 432 over x squared to the other side. Cross multiply and solve, and I get x squared, or x equals the square root of 432 over 3, which comes out to be, again, it's not on my answer key because I did my answer key wrong. And it comes out to be 12. This is 144. So x comes out to be 12. So this is 12, this is 12, this is 12. So take 216 and divide it by 12, and we get 18. So this is 18 by 12, which makes this over here 9 and 9. So we get a 9 by 12 shape. Okay, what was the question? Dimensions for the outer rectangle, 18 by 12. All right. There we go. That was it. All right. Sorry, I stumbled through some of these. It's like 5 o'clock, Friday afternoon. No excuses though. All right. Have a good weekend.